All right, so in this lesson, we are going to identify and interpret key attributes of linear functions. I'll just put key attributes of linear functions given a graph and a situation. So given a graph. So this first example reads, Jadit Sell starts a Mr. Lopez fan club. She is giving away buttons with his face on them. So remember that these are the, like, you get a circle and then like it has like, I guess it has my face on it or something. And then like you pin it on like your shirt or something. It's like that. So we have this graph on the x-axis or on the independent variable axis. It's the number of people that have walked by, and this is the number of buttons Jadit Sell has left in her bag. So remember, she started a fan club. She's giving away these buttons. We can see that the number of buttons she has left in her bag depends on the number of people that have walked by. So our dependent variable, the one that we sort of like are seeing change as a result of the other, is the buttons left in her bag. It's the one we care about, so to speak. It's the buttons left in her bag. So I'll put B for buttons. Don't just put buttons though, because this could be how many buttons she gave away. This is the buttons left in bag. In the bag. So I'll put number of. Number of buttons left in the bag. I don't know why this is looking so weird. Number of buttons left in the bag. That will depend on the number of people that have walked by. So P. So P, the independent variable, is the number of people that have walked by. So basically, as more and more people walk by, the number of buttons she has in her bag decreases because she's giving them away. So the y-intercept. The y-intercept, remember, is our starting point. So this is 0. Remember, this doesn't, it's showing me it doesn't count by 1. So 2, 4, 6, 8, 10, 12. So 0, 12. So 0, 12. And then what does this mean? So what's the interpretation? So this is the very beginning before anybody's walked by. She already has 12 buttons. She has, or Jadit Sell has 12 buttons before she starts giving them away. Cool. So let's make a table. In order to make this table, we need to locate some points. So we have one there. We have one here. We have one here. We have one here. We have them all over the place. Dot, 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 dot. But some of them don't make sense. And like we're just choosing the nice integer value ones. So we have the variable that I care about, which is buttons left in bag, will depend on the number of people that walk by. Okay. Now I know why that was there. We started off with 12, so 0, 12. And then 1, 2, 3. I might as well label these. So 3, 8. 3, 4, 5, 6, 7, 8, 9. Okay, so 6, 4. And lastly, 9, 0. So, oh, that's all I need. and my ordered pairs, so put P and then B, and then put a few of them, like 3, 8, and I don't know, 9, 0. Cool. So let's go ahead and talk about something called the x-intercept. So we know that the y-intercept is right here. The y-intercept is where the graph hits the y-axis. The x-intercept is where the graph hits the x-axis. So actually, I'm going to attempt to make a purple-ish color. Okay. And this will be my x-intercept, which is 9, 0. If you notice, in my y-intercept, my x is 0, my y can change, but in my x-intercept, the x can change, but the y is at 0. So 9, 0. And let's interpret what it means. So after 9 people have walked by, she doesn't have any more buttons left in her bag. She has 0 buttons left. So after 9 people walk by, make that a little nicer, walk by Jadit Cell has no buttons left. She has 0 buttons left. You can also say she has 0 buttons left. But I like to just say she has no buttons because I don't think in real life we usually say that or speak that way. All right, cool. So now we got to figure out the slope, the constant rate of change. And so the slope, the constant rate of change, we can do it one of 2 ways. We can do it from our table, if you prefer. So -4 plus 3, so -4. So, I guess put change in B over change in P. So negative over positive is a -4 over 3. And I can't reduce that, so that's it. But I can also, if you don't like that, you can just, something. Okay, cool. Now I know why. Okay, so it looks deceiving here, right? It looks like you go down 2, right 3, but remember, these count by 2s. So this is actually down 4. So this one's actually down 4, even though it's 2 spaces. I'm actually going to write that a little like this. So that's actually, I don't even know if that's even better, to be honest with you. I'll go like this. Down 4, right 3 spaces by 1, yeah, 3. So you can also do it like that. And then write down 4, right 3, change in B over change in P, and then a negative over a positive is a -4 over 3. You could also do it like that. It just depends which method you want to use. I would, if you do the graph method, I would just check the table to make sure. So -4 over 3, -4 over +3, yeah. So that's -4. Make sure, I guess we'll write it like this. Oh, this isn't change in Y. I'm not sure why I didn't catch this. This is the change in B, and this is the change in P. So change in P over the change in B is -4 over 3, which is -1.33 repeating. Now let's interpret that. So the number of buttons that she has in her bag decreases by 4 when the number of people increases by 3. So she gives away. She gives. That looks a little weird, so maybe I'll redo that one. She gives away about. Well, we'll just say she gives away 4 buttons every 3 people that walk by. Okay, cool.